walkway around the pool. So there's my picture, and just so we're clear, the distance or the width of that walkway is going to be 3 feet. I don't know, I did feet. So let's find an expression for area, and one of our expressions is going to have a rational term in it. That's why we're doing it in this section with rational equations. So we want the area of the plot of land and the surrounding walkway. Okay? So you guys tell me, if from here to here is 1500 over x, what would be an expression for the whole length across? Plus what? Yep. So here you go. I'm going to write area. I'm going to write 1500 over x plus 6, because that is the length of this entire thing. What I do? I want to find the area of everything. So if I were to shade, it's this whole rectangle. Okay? And what's the width? X plus 6. Okay. So we are going to solve graphically, but first I would like to write my expression a little bit more simplified. So I am going to multiply those things out. If I would multiply 1500 over x times x, wouldn't the x's cancel? Yep. So we'd be left with 1500. If I were to do 1500 over x times 6, wouldn't I have to do, let's see, 1500 times x? I don't know where my graphing calculator went. Should try to find that, huh? Okay, so that would be plus 9,000 over x when I multiplied those two together. Then what's this? Plus 6x plus, what, 6 times 6? 36. So now I have at least a little more simplified area equation. Let's see here. I can add the 1500 and 36 together, right? Plus 9,000 over x plus 6x. So there's an equation for my area. Let's find the dimensions of the land that has the least area. So the only way to find this is graphically and look for a, what did I ask for? The least area. It's making me nervous because I lent it out to somebody. Nathan. And I don't have it in here. I would. And now that makes me nervous. Who sees Nathan next hour? Nathan? No, Gaston.
I do.
You see him next hour?
Yeah.
Can you tell him to return my calculator?
Yeah.
When you see him? I don't think he probably intentionally took it. I think probably what happened is he just left class 6 hour because his priority wasn't returning my calculator. He probably has important things to do after school. All right. But when you see him, ask him please to bring it. Thanks. All right, so we're going to graph this. Let's see if we can see with just a standard window. Ooh. Gosh, the glare though. The glare. I think I'm going to need. Yep. I know, so now he wasn't putting the graph on, so now I got to type it in, because, geez, John. You're an observer. Okay. Oh, no, I typed in the wrong thing now. Hold on. 1536.
You need parentheses though for the 9,000.
You don't, unless there's a sum or difference there. Okay, so, it doesn't look like I'm seeing what I need to see. Well, first of all, I need to look over here, right? And also, if the area of this part is 1,500, the area is, I might have to go up a little higher, I guess is what I'm saying. So, how about we just start with 0 to 100 and see if I can see anything for the X min and X max. No, what? It shouldn't be. It shouldn't be though. I know I saw it on the other side, but then go. Can you see it on the other side? What's your window, Chris? Okay, say it again. -10 to what?
-30, 10. And then I have -10.
And you see it? Okay, but that's a maximum.
Yeah.
Okay, so Joe, you said you saw it on the other side when you zoomed way out?
Yeah, well, I think pretty far out. Never mind,
This is troubling.
Oh, I found
You know what it's supposed to look like?
Never mind. I found it.
No.
I found it. It's on the other side.
Oh, phew. Well, it needs to,
30,000.
it's 30, because it's so big. 1536.
Well, you can
Throw
probably-
10,000. That is true.
Did it find it when you did zoom
You go
here?
10,000.
It wouldn't even with 1,000. Oh yeah, duh. 1536. Oh my gosh. This is why the area of the rectangle is 1,500. So if the area of just the inner rectangle is 1,500, isn't the area of the whole thing going to be bigger than that? Yeah. So that's why. Okay. So, but I'm going to make this one go up. I guess is what I'm saying. There we go. Okay. I didn't make my X go up, I just made this, because look at, if the area of the rectangle, the inner rectangle is 1,500, this is going to be bigger than 1,500, agreed? Okay. So, I went up to 10,000. I can make that a little smaller, can't I? 8,000 maybe? Oh, sure, I can even go, do you see the minimums right there? Okay. So I'm going to make my X max a little smaller so I can see the minimum more clearly. Okay. So I'm going to even make it smaller still. Oof. So it's going down and then it's going to come back up again. Okay. Do you see how it's down here? We saw in the big window, do you remember when we saw it did come back up again? Okay. So let's see if we can find the minimum then. Alright, it's still going down right here, so I'm going to try to figure out when I see it going back up, and I did. Do you see how I saw the Y going back up? Because it's kind of a small. Alright, so we're going to go here. We're going to go down and wait till it comes back up again. Okay, so I get that it is X is equal to 38.729 if I truncate, or truncate means you just cut off the decimal, 730 if I don't. Okay, let's figure out then, it says the dimensions of the land. So that's what X is, right? And let's plug it in to find our area. So first, we're going to do 1,500 divided by 38.729 plus 6. That's going to give us the length. So 44.73 feet. And then let's do x plus 6. Hey, what is it? Those would be the dimensions. It's a square. Oh. So I plugged x into my dimensions up here, Carmen. Okay,